Okay, this is for my honor students because it's important that you know how to evaluate some trig functions for angles that are bigger than 90 degrees, things that you wouldn't see inside of a right triangle, but they're still angles that occur in the real world and you have to deal with. So let's start with something like a sine of 480 degrees. For starters, 480 is a really big number, so I want to start by finding a coterminal angle by subtracting 360. I'd say, okay, 480 degrees is the same thing as 120 degrees. So it's a lot simpler just to think of sine of 120, and I would probably go ahead and sketch that angle right here. If straight up is 90, this is 120. And that means I have landed in quadrant 2. Important to make a note of that. And then I would go ahead and figure out the reference angle. Well, if this is 120 degrees, I have another 60 degrees to get to 180. So 180 minus 120 means that this reference angle would be 60 degrees right here. And I would drop to make a right triangle. So you always drop your other leg to the x-axis. That way that reference angle is the angle you're talking about for this right triangle. Now, once I've done that, I could use the right triangle and the reference angle to find the trig ratios for this triangle. Now, one way we can do this is a 60-degree angle. You might have learned in your geometry class about some special right triangles. There's basically a ratio that says if this is 60 degrees, this is always a ratio of 1. This is always a ratio of 1 to square root of 3 anytime it's a 60-degree angle. That's going to be true for any time you have a 60-degree angle. If you consider your hypotenuse to be 2, then this side over here, the short leg is going to be half that side, and then Pythagorean theorem will give you square root of 3 for the other side. That works for any time you have a 30, 60, 90 triangle. But anyway, moving on. Our trig functions then for each one of those. If I wanted the sine, and for sake of space, I will not write the angle beside of it, but the sine value would be the opposite, which is, in this case, square root of 3 over 2. The cosine value would be the adjacent, in this case, 1 over 2. The tangent would be the opposite over adjacent, so square root of 3 over 1. And then if I wanted my other trig functions, I could just flip these upside down so that cosecant was a 2 over root 3, which became 2 root 3 over 3. Ran out of room there. Secant, I would flip it upside down so it would be 2 over 1. And then tangent, I would flip that upside down to cotangent, and that would be 1 over root 3, which would rationalize to root 3 over 3. Now, once you have those trig functions, then you need to pay attention to your signs. If I am in quadrant 2, you notice it says that sine is positive. So sine and cosecant are positive, but everything else is a negative. And one thing that can be helpful with this is this shortcut I've noted down at the bottom. It says that this opposite side of 3 is basically would give you a y coordinate at this point. So this is equal to y. And then this adjacent of 1 is the x coordinate of this point in the corner. So that point in the opposite corner would have a value of a negative, would have a value of negative 1 and root 3. So I could have basically used my negative 1 to know the numerator for my cosine and my root 3 to know my numerator for my tangent. So that hopefully will help you to see some ways you can use this information to help you get some of these things correct.